Hi, good afternoon. My name is Kevin, and I've been working in the Simmons lab this past summer on the automated construction and visualization of bibliometric networks for understanding research collaborations. Scientific knowledge is growing day by day, and it's becoming more diverse and covering much wider ranges of different technical topics. Everybody knows that scientists do not work alone. In fact, they work with their graduate students, lab personnel, and potentially other researchers. In fact, interdisciplinary research collaborations are becoming more and more common as they can help researchers increase their research project productivity, drive new and innovative ideas, as well as help foster academic connections within their community. Now, it can be very subjective to say that collaborations are increasing within interdisciplinary research, but if we can determine this objectively, then this can help create deeper insights on these collaborations. The study of bibliometrics in library and information science looks at using statistical methods in order to analyze publications and then create meaningful insights. An example of this is through the use of co-authorships, seeing which authors publish with which other authors, and then performing what's known as a social network analysis to produce statistical evidence. So what is a social network analysis and how is it performed? So first, we would retrieve our publication data sets from research databases such as Scopus or Web of Science. Afterwards, within each publication, we can generate what are permutations, seeing which authors are collaborating with which other authors, and generate what are known as co-authorship networks. In this simple example, each circle here is represented as a node that would represent each author, and each black line here would represent a connection or an edge that would connect authors based off of the publication that they both would have contributed to. After generating these co-authorship networks, we can then compute what's known as a social network analysis in order to compute relevant metrics, in order to ask ourselves key questions, such as who are the key researchers that are driving research productivity in a network, and whether or not interdisciplinary collaboration is actually increasing. So currently, the research gap in the field shows that there is a need for alternative network analysis tools. The picture on my right shows an example of an institution collaboration network that can be generated with available software. In this example, we can see different institutions that are collaborating with other institutions based off of recent COVID-19 papers. Now, while this software is very useful to show these visualizations, they do lack some key features, such as being able to incorporate dynamic and interactive visualization or the retention of bibliometric data. So this is important because having that dynamic and interactive visualization can illustrate and bring about important aspects to your network, such as how do networks change over time, and create a more compelling narrative. Retaining bibliometric data can also help create the context behind each connection, such as if these institutions are collaborating within a paper, what is the impact of that paper, and what are the citations that paper has. So now we can ask ourselves, what tools can we create and potentially use in order to better understand these research collaborations in network analyses? So my main project objectives for this past summer was to, 1, design a software tool to automate this network construction and metric calculation. 2, demonstrate possible dynamic and interactive visualizations of these constructed networks. And then 3, investigate research collaboration prior to and after the launch of the Ted Rogers Center for Heart Research, or the TRCHR. So a little bit of background about the Ted Rogers Center. So this started as an interdisciplinary collaboration back in 2014 between U of T, UHN, and SickKids in order to unite researchers of different backgrounds, clinicians, and basic scientists to advance cardiovascular research. So the way that this software was developed and the methodology used to perform this analysis was through using open source Python libraries while extracting information from the Scopus database. First, we would generate a list of authors that we would like to generate a publication dataset for. Here is a screenshot of the user interface that we developed, where a search of the author name can yield all possible authors, and then the user would have the ability to confirm which author they would like to extract publication information from. The next step after generating our list of authors would be to construct our network files via a custom Python algorithm. After generating our network, we can then analyze key network metrics that can help develop insights into these co-authorship relationships. So the key metrics we wanted to look at were first centrality, which represents how well connected an author is within the network. Betweenness, which would represent how much of a key stakeholder or how much potential leadership they might have within the network. Closeness, which represents the proximity of an author between all other authors within the network. And eigencentrality, which represents how well an author is connected to other well-connected authors. After analyzing metrics, our program is also able to generate appropriate files, which can then be downloaded and sent on Kumu, which is an open software website online that allows for more dynamic and interactive visualization while retaining bibliometric data. So here's an example of what one of our files can produce on the Kumu website. So here we looked at 83 unique authors over U of T, UHN, and SickKids in the Ted Rogers Center, and we can see that our files retain bibliometric data, which can provide other filtering options on the Kumu website, such as the institution, the number of citations that the institution based off of color coding, or the impact of an author based off of citations by the size of each node. So these are just examples of potential filter settings that can be used to customize your network. And then between each connection, we can also see between authors which publication they were associated with, as well as the impact of the publication via their citations and the original DOI and year of publication. We're also able to incorporate dynamic and interactive visualization. So here I filtered the network to include connections and collaborations between 1991 and 2014, prior to the launch of the Ted Rogers Center. And then here I can apply filter settings and then update the network based off of new connections from 2015 to the present time. We can clearly see that there's a lot more connections just visually between the network, and also a lot more connections that are also occurring institution-wide between other institutions as well. As such, we also see that there was a huge increase in connections between this 5-year time span compared to 1991 to 2014. With the metrics that our program can produce, we can also perform statistical analysis. We're looking at different network metrics. We can see a significant increase in the average degree centrality, or how well connected an author is within the network, and also how close and proximal an author is relative to all other authors in the network. These statistics also help support a possible claim that the Ted Rogers Center will have helped foster interdisciplinary collaboration in research pursuits. So in conclusion, a new software tool has been developed in order to help automate the construction and analysis of bibliometric networks, coupled with possible dynamic and interactive visualizations coupled with Kumu. Centrality and closeness have increased through co-authorships within the Ted Rogers Center before and after its launch. And the impact that this research will have is providing that alternative workflow in order to construct networks with better understanding of research collaborations, which can potentially yield more network insights and help possibly inform new research initiatives and create more compelling and dynamic visualizations. The next steps would be to look at optimizing software performance, improving modularity to potentially scale to other platforms, and integrating with other databases for even more possible wider applications. So I want to thank Dr. Craig Simmons for providing me the opportunity to work on this project for the summer, Noah Frank from the Ted Rogers Center for helping me in for working with him on establishing the workflow, Henrik for helping to develop the code, the Simmons Lab for the help this past summer, as well as the Ted Rogers Center and the Translational Biology and Engineering Summer Research Program for summer funding. So thank you, and I'll be happy to take any questions.
So thank you, Kevin, for your presentation. And now I would like to address the judges and ask if you had any questions, and if you could please unmute and ask them.
Sure. Maybe I'll start. It's Marcus Bussman. So Kevin, that was really well presented and an interesting presentation of your work with Professor Simmons. So maybe just a broad question. So you clearly have developed a tool that that illustrates that the Ted Rogers Center, for example, has led to more research relationships between people at these three institutions. Does your tool tell us anything about the impact of that work, of those connections?
Yeah, so as the example I just showed there just showed the connections, but what we can also do is we're applying new filter settings into our program. So then you can also generate the connections based off of how you want. Oh, sorry, can you hear me?
Yep.
Okay, so you can also filter your connections based off of their characteristics. So that's a current drawback that other software programs can do. And with the help of Kumu, you can apply this filtering based off of your connection data. So for example, if you only want to look at connections specifically for journals with high impact, or for papers with only a certain number of citations, then you can apply those filter settings on Kumu, because the files that our program can produce allows you to retain that information and allow for the filtering to happen.
Thank you.
Kevin, I think this is really interesting work. Sorry.
Sorry, could you repeat that?
Yeah, that's fine. I'm just wondering if you can talk about how this software or this analysis would be used to make recommendations or changes to how people collaborate. Yeah.
Yeah, so I think what we've also been able to done with the program is help compute these individual metrics for each author. So through the use of visualization and through looking at the statistics our program can produce, we can identify key authors that may not be that well connected within a network, as well as potential key authors that may be very well connected and associated with specific research areas. So for example, if there are new professors that are joining these interdisciplinary programs, it can be easier to identify these new professors because they would have low levels on these metrics. And maybe a quick way to get them to integrate into these programs is by looking into potential collaborations with very more well-involved professors who have established much more progress into their career.
I got two quick questions, Kevin. I really like the talk. You know, lots of times when people collaborate, they might actually do multiple papers together, not just one, right? That often happens. You start into a long-time collaborative relationship and you're cranking out articles together. So does that play into these graphs at all, these multiple collaborations? And the second question that I had is that, you know, you compared two time periods. I think it was post 2015 and pre 2015. And those time periods, at least it seemed to me, have different numbers of years in them. So you kind of want to normalize the data to per year, per PI or something like that, right? To see if more collaboration is happening.
Yeah, very good question. So to answer the first question, definitely as researchers might want to collaborate more and more often together, that is taken into account in the networks that we generate and the files that we produce. So that is shown, especially when you go onto Kumu, you'll be able to see if two authors have multiple connections, each connection will be associated with a different publication. So that is definitely present within our files. As for your second question, yes, it should be normalized based off of a similar time span in order to make a better comparison. And that's something that at the time I didn't consider, but it was only afterwards, after receiving feedback, that could have potentially been done, but we just didn't manage to put it in time.
I see, got it. Okay, thanks.
Okay, so thank you, Kevin, for your presentation.